Hi, let's take a look at how we can use Git to collaborate with everyone else and write code smarter. Well, what is it? Essentially, Git is a way of controlling your code versions. We call it version control. The idea is that all your code is going to be hosted on a server and you can collaborate with everyone else at the same time without having to write over each other's code. Learning Git is quite a challenge, mainly because the different vocabulary we use here. Let's go through each of these words and see what they mean. A repository usually is a place where all your code is contained. You can think of it as a cloud-hosted folder where each of the folders is going to contain the source code for your program. A branch essentially is a sequence of commits you've made on these files. Usually all the projects usually have a master branch which contains the default release for that given program. All the branches going to have its own name, and in these diagrams I'm going to use the lines to denote the time. So the further left you further right you go, more time has been passed. Often there's going to be multiple branches most of the programs going to be having. So in this case I'm going to be using a new branch called Arithmetic to implement my maths program. So far I've created one package called Arithmetic, and I'm going to create another branch for some other package. I'm going to call it calculus for now. Alright, so let's make some commits. So if in these diagrams, the circle sort of denotes commits you make on your files. In our branch Arithmetic, I'm going to make my first commit and add the package Arithmetic. It's just a folder for now. On the next commit, I'm going to make 4 different files, and I'm going to put the 4 different arithmetic operations we can perform as functions to keep it simple. Keep in mind, Git only saves the difference between the commits. It doesn't save all the files every time you make a commit. So all your commits are essentially just deltas of file changes. Each of the commits is going to be having a hash and also a message. We often use the message to describe what change it does on the file base. For instance, adding package just simply adds a folder called arithmetic, for instance. The additions are not the only ones captured. We also capture removals and also updates to the file system. Cool. So far we only have added files, but we haven't implemented any code. So let's take a look how that's going to be done. So on the addition Kotlin file, I'm going to add a function. Hopefully this is pretty straightforward. I'm just adding 2 numbers and returning its value. The green indicates an addition in this case. I've made a typo. Instead of N2 I just typed NR. So I'm going to fix that in the next commit. By fixing it, the Git only captures the difference or the delta between the 2 files. So hence that only that line is captured in this commit. Commits also captures removals. So in the next commit, I'm going to sort of optimize and refactor my function. I just removed the 3rd line and it captures the 3rd line. Alright, so I also implemented calculus, and it's in a different branch if you remember what we did before. And that has its own commit, and I want these changes to be merged into my arithmetic branch, which we can simply do using a merge. And that's going to create its own commit. And that commit's only going to reflect the additions from the merge. Alright. What I haven't told you about right now is that these changes we've done is only going to be on the local machine. There's going to be a duplicate hosted on our server. We often call this the origin copy. It's going to be a mirror copy, but the only difference is that we haven't pushed any of our branches to the origin. By pushing to origin, what we're pretty much doing is we're just duplicating the changes we've done locally and replicating that on the server. The pushed branches looks very exactly identical, and it copies each of the commits one by one, and also the merges. A fetch is when you want to synchronize our origin with the server's origin. So for instance, when someone has done some other work, let's say it's one of your friends implemented algebra package, and by fetching, we are just synchronizing our origin with your friend's origin. If you want to take a look what your friend have done, you can check out their branch. By checking out, what you're pretty much doing is you're just copying their branch to your own local branch as your local branch. All right, hopefully what I've done so far is pretty clear. Now let's take a look at what we can do with our branches. We can delete our branches. Essentially what deletion is going to do is just going to prune the branch, and it's going to take it off from the server. We often don't need to keep the branches around because our branches are essentially just a collection of commits we can recreate later on if we wanted to. Now, often our master branch is on lockdown. We don't want people to merge into our master branch because the master branch is going to be the stable release of our software. So in order for people to actually merge their features on their own branches with the master, they'll have to make what we call a pull request. A pull request is a formalized way of making sure your team knows what you've written and what you're trying to merge into the master branch. Once you make a pull request, it'll eventually create what we call a review. In the review phase, everyone has to go through the code. Your first friend might approve the changes, whereas your second friend might not, and you can address the changes you've done in order to resolve what you've said, and eventually everyone would agree. Once the review is done, you are free to merge, and that merge is going to be reflected as commit, and you can delete the branch. And that's what the basics of Git are. Keep in mind, we only went through some of the terms. There's a lot more to explore.